Hughes Brothers has tested about 120 full-scale structures. I have seen about a quarter of those, maybe a third of those. And we've also tested, in addition, over 1,300 different components, from bolts and braces, yoke plates, pull bands. And I'm a little embarrassed, but a little proud also to say that I've seen half of those. I guess that means I'm old. The records that we have indicate we conducted our first test sometime in the early 1930s. We probably did more than that because the founders would have been breaking things before they actually got an engineer on board that was telling them, hey, you need to keep records. But from what I could find, there was 120 some structure records and over 1,300 different component tests. It will take us about, I would say, 4 to 6 weeks to manufacture in the factory, but to actually install it is going to be several months. You have to have time for the concrete to cure and to frame it out on the structure site, and it's very highly weather dependent. But once we start pulling on it, we can get it on the ground in an hour or 2 hours. So it's pretty quick compared to the time it takes us to prepare.
We tested this steel structure on wood framing because we wanted to show how adaptable not only our designs were, but steel and wood can be used together, and framing can go on any kind of pole and any kind of framing.
So during the structure test, the first thing that we're going to do is take deflections at a negative point so that we now have a baseline, and then we begin lifting the vertical weights for the shield wire and for the conductor. And then we can take again some more deflections. Once that is done, we start pulling on the structure in a transverse direction on the shield wire and the conductor. And there's a little bit of finagling that has to go on to try to get the dynamometers on the other end to balance, because when you pull on one, the other one goes down.
Being on the end where the structure fails, when applying the loads, it's nerve-wracking, but as it does come down, it's kind of scary in a way because you don't know what the cables are going to do and what the structure is going to do. But when it does crash to the ground, it's pretty cool and satisfying to see.
We were very happy with the results of the test. We predicted that they would fail right by the X-brace, and that's exactly what happened. We wanted to show that steel framing would work on wood poles regardless of the size of the structure, regardless of the type of steel framing, and that worked out quite well. And I think there were some customers there that hadn't really realized that you could do that. In fact, it was kind of strange.
The force a structure can withstand just kind of depends on how much you want it to.
We can make a structure withstand any load that you want to pay for. I'm an engineer, and that's what we do. We can make them withstand high winds in Florida. We make them withstand really heavy ice in the Midwest of Iowa and Nebraska, for example.
If you have any further questions, please call Hughes Brothers and ask for Joe, and I'd be more than willing to go over anything that you might have.
If you have any other questions about component testing, or you want to see a component break or a structure test question, please contact Hughes Brothers. You can reach out to me personally, Larry Vandergren, or Joe Traster, our engineering manager, would be happy to answer your questions.